بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 7.5 strategies of integration. Three integrals are given. Although they look similar, may require different techniques of integration. Evaluate the integrals. Well, here in this section, I will not solve the questions until the end. I will just give you the first steps in each question or the idea of the question. So if you look to the first integral, if you take u equals 1 plus x squared, then dx du would be 2x dx, and you can easily solve this integral. It would be equal to half 2x dx as du over u, and you continue half ln absolute value of u plus c, and then you write u as x. U would be 1 plus x squared. So we can solve the first integral by substitution. The second integral is just tan inverse x plus c. That's just a formula. Integral of 1 plus x squared is tan inverse x. While part C, we have a rational function. So we can write it integral a over 1 minus x plus b over 1 plus x dx. And we can find ab using the techniques in section 7.4 about partial fractions. So 1 minus x squared is factored into 1 plus x times 1 minus x, and you continue as section 7.4. Here, if you look to the first integral, again, if you take u equals x squared minus 1, then it's a usual substitution because du is 2x dx. So I need 2 here, half here, and I continue as usual. While part B, if you know the formula, this is in fact c inverse of x plus c. Or if you don't know the formula, you can deal with it using 7.3, section 7.3, trigonometric substitution. You have x squared minus 1, so you can take x as secant theta. Then dx would be secant theta tan theta d theta. And the square root of x squared minus 1 would be square root of secant square minus 1, which is tan square. So it would be tan theta square root. So the integral would be integral of 1 over x is secant theta, and the root, the radical is tan theta, and dx is secant theta tan theta d theta. So these cancels, and we will have integral d theta, which is theta plus c, and theta x is secant theta, so theta is secant inverse x plus c, and you get the same answer. Here also we have x squared minus 1, so you solve it with this technique, trigonometric substitution, taking x as secant theta, and continue like above. After simplifying, okay, you will find that this integral will become integral of tan square theta d theta, and you write it integral secant square theta minus 1, and you continue as usual formulas. Secant square theta minus 1, because tan square plus 1 is a secant square. In the first integral here, if you take u as ln x, usual substitution, then du would be 1 over x dx. And this integral would be integral u du, and you continue. Here, integral len, so we use integration by parts. You take u as ln 2x and dv as dx. And du would be the derivative of len 2x, which is 1 over 2x times 2. So it's in fact 1 over x, and v is x. So it is equals to uv minus integral v du, and v du is just d, this is dx, would be just dx, because x times 1 over x is 1 times dx, and integral dx is x. Here, integral x times ln x, this is also by substitution. You take u as ln x and dv as x dx, of course, and du would be 1 over x dx, and v would be x squared over 2. So now this integral would be u times v, okay, minus integral of v times du. I have half, and x squared times 1 over x is just x, and this is easy, and you can continue. Integral sine square x, well, we know how to deal with integral sine square x. We write it as 1 minus sine 2x over 2, and we continue. We solved this in section 7.2, sorry. Also in 7.2, we learned what to do with sine cube. When we have an odd power, we take u equals to cosine. And to take u equals to cosine, I write it sine square times sine x dx, and then sine square, I write it 1 minus cosine square x times sine x, and now you take u as cosine x, and you continue the integral. Sine 2x is just the integral of sine is negative cosine 2x over 2 plus c. Here I have a rational function. So if I write this as 1 over, if I factor the denominator, x minus 3 times x minus 1, so I can write it a over x minus 3 plus b over x minus 1, and I can continue as section 7.4. Here, if I factor the denominator, I will have 1 over x minus 2 to the power 2, because this is a perfect square. And now I can evaluate this easily. It is x minus 2 to the power negative 2, and the integral would be x minus 2 to the power negative 1 over negative 1 plus c. While here, I have plus 5. So if you factor this, it cannot be factored. This polynomial has no real zeros. So what I can do, I can write it x squared minus 4x plus 4, and then plus 1. And we have seen that in part B, x squared minus 4x plus 4 is just x minus 2 to the power 2 is a perfect square, and then plus 1. And now if I take u as x minus 2, d would be equal to dx, and I can write this integral as 1 over u squared plus 1 du, and this is tan inverse u plus c, or tan inverse x minus 2 plus c. Well, what to do with x times cosine square x? I will use integration by parts. Sorry, this is x squared, not cosine square. So x squared, that's easy. I take u equals to x squared, and du would be 2x dx. So the integral would be integral of, I need 2, so half outside the cosine x squared, cosine would be cosine u, and 2x dx would be du, and I continue easily. Here I use by parts, but before using by parts, I can simplify the problem by writing cosine square as 1 plus cosine 2x over 2 dx. And then this half I can take it outside, and I'll have x times 1x plus x cosine 2x. Now the integral of x is easy, and the integral of x cosine, you do it by parts. You take u equals x, du would be dx, and you take cosine 2x equals dv. So v would be the integral of cosine 2x, which is sine 2x over 2. And then v du would be just the integral of sine 2x. Easy to continue. X squared cosine x is also using by parts, but I can use the quick method. I will take u as x squared, and the derivative of x squared is 2x, and the derivative of 2x is 2, derivative of 2 is 0. And dv would be cosine x, and the integral of cosine x is sine x. Integral of sine x is negative cosine x, negative sine x. Please review section 7.1 if you don't know what I'm doing. And here, now the answer would be x squared times sine x minus 2x times negative cosine, so it would be positive 2x cosine x, and then minus 2 sine x plus c. That would be the answer. Well, here I have x squared times e to the power x cube. Well, if you take u as x cube, then the derivative is 3x squared dx, and I have x squared, so this would be 1 over 3 e to the power u du, and you continue easily. While here I have x squared times ex, so I use integration by parts, where u is x squared. You can do it like the one I did just 1 minute ago, like this one, x squared times cosine. Very similarly, exactly, you find the integral of x squared ex. X cube ex square, well, I do not have here, I have a problem with x squared and the power of e. What can I do with this x squared? Because the derivative of x squared is 2x, and I have more than what I need outside. Anyway, I'll start by taking u as x squared and see what happens. Du would be 2x dx. Well, I have x cube here. I need 2x, and x squared will be left, and I have e to the power x squared and dx. Well, this would be x squared. This x squared I can write it u, because u equals x squared, and ex squared would be eu, and 2x dx would be du. And okay, now I can continue with integration by parts easily. Well, here, what can I do? The derivative of ex minus 1 is outside. So if I take u equals ex minus 1, then du would be ex dx. And this would be just integral of square root of u du. Here, if I take e to the power x, as u, then du would be e to the power x dx. So I'll have ex dx would be du, and here I have 1 minus e to the power 2x is just e to the power x square, so u square, and integral of 1 over 1 minus u square under the square root is just sine inverse u plus c, and then you can replace u by e to the power x. Here, what can I do? There is no derivative outside, nothing to, no formula, no section to follow, I mean, no special technique. So I have a square root, so let me take the square root, let me call it u. So u equals e to the power x minus 1. Now I need to change this integral from x to u. So I will solve this for x. So I have u square equals ex minus 1. And I can find now, or let me write it, u square plus 1 equals ex, and let me apply ln to both sides. So ln u square plus 1 would be x. And now I can find the derivative with respect uh, the derivative. So the derivative of the left hand side, 1 over u square plus 1 times 2u du would be equal to dx. So now I can change this integral to u. I have 1 over u, square root is u, and dx I can write it 2u over u square plus 1 times du. And u is cancelled with u, and I will have, you can also write 2 outside, and I will have integral of du over u square plus 1. And this is just tan inverse u plus c, and you can write it tan inverse ex, square root of x minus 1 plus c. Okay, evaluate the integral. If we take u here as 1 minus sine x, then du is negative, the derivative of sine is cosine, negative cosine x dx, and this would be du over u, and you continue easily. Square root of 2 is just a number, so the integral would be 3x plus 1 to the power square root of 2 plus 1 over square root of 2 plus 1 times 1 over 3, the derivative of 3x plus 1. And you can evaluate this from 0 to 1 and write the answer. Here you solve by parts. I take u equals ln y, du would be 1 over y dy, and dv is y to the power half or square root of y. V is y to the power 3 over 2 times 2 over 3. So the integral would be u times v from 1 to 4, okay, minus integral from 1 to 4 v du, 2 over 3, you can take it outside, and y to the power 3 over 2 over y is just y to the power half, and I can continue easily. Well, here I can take u as sine inverse x, and then du would be 1 over 1 minus x square dx, and the integral would be integral e to the power u du, and you continue easily. In fact, I can take here u equals e to the power sine inverse x also, and then du would be e to the power sine inverse x times 1 over 1 minus x squared dx. So this integral would be integral just of du. So the answer would be u plus c, or e to the power sine inverse x plus c. The same answer in both cases. Well, I have here ln y and y. So if I take t, if I call t equals ln y, then dt would be 1 over y dy, and then this integral would be ln t dt. And you can continue easily by parts. We know how to find the integral of ln. Go to section 7.1. Well, here I have x over 2x plus 1. The derivative of this is 2. It is not this one. Uh, I cannot use here section 7.4 rational fraction because I have only one term, okay? One term. But what can I do is, what if I take 2x plus 1 as u? Let me see what would happen, okay? So du would be 2x dx. So I have 2 here, so there will be half outside. So the integral would be half times. Now 2x dx, okay? 2x dx is just du, and this is u to the power 3. There is a mistake. The derivative of 2x plus 1 is just 2, all right? So what to do with x? Well, x I can find it from here. Solving this equation for x, x is u minus 1 over 2 over u cube, all right? And this 2 times dx would be du. And now this half is just below in the denominator. You can write it here. And you can take it outside. And you can divide u over u cube minus 1 over u cube and continue easily, because this is u to the power negative 2 and that one u to the power negative 3. Question 15. Yeah, look here, I have x to the power 4. So if I take u equals x squared, then du would be 2x dx. I have 2 here, so I will have the integral would be half times integral of du over x squared plus 9, x to the power 4 would be now u squared, because x squared is u. And we know that the integral of this is 1 over 3 times tan inverse u over 3 plus c, and then you write u as x squared. I'll stop here and continue in another video.